Hello everyone. In today's video we will see what is growth curve. A growth curve is an empirical model of the evolution of a quantity over time. Growth curves are widely used in biology for quantities such as population size or biomass for population growth analysis. A growth curve is a graphical representation of how a particular quantity increases over time. Growth curves are used in statistics to determine the type of growth pattern of the quantity. It may be linear, exponential, or cubic. Once the type of growth is determined, a business can create a mathematical model to predict future sales. An example of a growth curve is a country's population over time. A growth curve is a way to visually represent the growth of some phenomena over time, either in the past or into the future or both. Growth curves are typically displayed on a set of axes where the x-axis is time and the y-axis quantifies the phenomenon in question. Growth curves are readily used in a variety of applications from population biology and ecology to finance and economics. The growth curves are of two types. One is J-shaped curve and another one is S-shaped curve or sigmoid curve. Now we will see what is J-shaped curve. In the case of J-shaped growth form, the population grows exponentially, and after attaining a peak value, the population may abruptly crash. This increase in population is continued till large amount of food materials exist in the habitat. After some time, due to increase in population size, food supply in the habitat becomes limited, which ultimately results in decrease in population size. For example, many insect populations show explosive increase in numbers during the rainy season, followed by their disappearance at the end of the season. The following equation exhibits J-shaped growth, that is dn divided by dt is equal to rn. Here dn divided by dt represents the rate of change in population size, r is the biotic potential, and n stands for population size. Now let us see S-shaped or sigmoid curve. When a few organisms are introduced in an area, the population increase is very slow in the beginning. That is positive acceleration phase or lag phase. Then in the middle phase, the population increase becomes very rapid. That is called as logarithmic phase. And finally, the last phase, the population increase is slowed down, that is negative acceleration phase, until an equilibrium is attained, around which the population size fluctuates according to variability of environment. The level beyond which no major increase can occur is referred as saturation level or carrying capacity. It is K. In the last phase, the new organisms are almost equal to the number of dying individuals, and thus there is no more increase in the population size. The S-shaped sigmoid growth form is represented by the following equation, that is dn divided by dt is equal to Rn into bracket k minus n divided by k, which is also equal to Rn into bracket 1 minus n divided by k, where dn divided by dt is the rate of change in population size, R is biotic potential, and n is population size. K minus n divided by k, or 1 minus n divided by, which is written as both, is for environmental resistance. Thank you. In the next video, we will see community structure and species diversity.